Welcome to Digital Toolbox. This is part 4 of the jigsaw joint tutorial definition. And to get started, I'm just going to go straight over to where the sliders are located, where that controls our evaluative lengths. And I also went in and reorganized our definition so we can read it easier. So as you can see here, anything that's above 0.5 controls the definition. Anything below 0.5 controls the definition's arc or the joints. So if I move one of these two sliders down to below 0.5, it no longer looks like the joint that we want. So to create an expression out of this, I'm going to grab the one variable expression, and I'm going to type in 0.5 plus open parentheses 0.2 multiplied by x. And you'll see why we need the x in a bit. And I'm going to copy and paste this and then change the positive to a negative, and then commit changes. Go to grab a one variable expression, grab a number value button. I'm going to change that to 1, and I'm going to put that into x. So 1 will be 0.7, and that will be going to the lengths that are above 0.5, and the other one will be 0.3, and that will be going to the other buttons. So 0.3 will go into the two middle ones, and then 0.7 will go into the outer buttons of the evaluative length buttons. And I'm just going to move this all the way across, and then what I'm going to do is grab this curve and move it closer so I can work faster. So just take my word, if we flip this curve in Rhino or in Grasshopper, the joint will flip. So go to curve and grab the flip. I'm going to flip the curve. I'm going to unpreview this, and then we need something so we can toggle between the two curves. So we can go to logic and grab the VB script. X will be on curve, Y will also be on curve, and then we go to input manager and add in toggle as a variable. Click OK, and this will be a boolean for on type, for a type hint. And then for output manager, I'm going to add in B. Double click on the VB script. For my code, I'm going to write an if and else statement. So if toggle equals true, then A equals X, B equals 1. Else if toggle equals false, then A equals Y, B equals -1. Why do we need -1 instead of just +1? It's because when we flip the curve, we also need to flip the evaluative numeric values to its inverse value, which is the negative of it. So hit OK. So the flip curve will go into Y, and then the curve will go into X. It spits out a number, which is -1, because I think by default the toggle is on false. So put a toggle to it. Hover over B, it says -1. We make this true. Now the value is 1. So we can input that into the expression that we created for the evaluative lengths. And then what we need to do now is divide our curve into number of segments so we have multiple joints. So go to curve, go to division and grab a divide curve. And then I'm going to go to parameters and grab a number slider. I'm going to edit this from floating points to integers, upper limit of 10, and the value be 2. So now we have 2 points, and then we need to create lines from these points. So I'm going to go to curve and grab the line. And before we do this, we need this point connecting, which is the 0th value, into 1, and then recreating a line that goes from 1 to 2. So I need to go to logic and grab the list item. I also need 2. 1 will go into B, 1 will go into A, and the points will go into the list. And then I need a series. Copy and paste. This will go into I. And the values, which is C, will be the values of divisions. And the starting point for 1 will be 1. So now if you hover over E here, it says, well, that's not good, but here, create a post-it. So now you can see that it goes from It's not a great example here, but here we connect it goes from 0, 1, and this one goes from 1 to 2. So when we create the item, it says from 0 to 1 and then 1 to 2, which gives us our lines. From here, you would assume that we can connect this line into the endpoints and then reconnect the curves to its respective areas, but it's reading as, in Grasshopper it's reading it differently, so we need to explode this curve into separate curves before we can do that. So go to curve and go to analysis and grab the explode. We're going to explode these lines into separate segments, and I'm going to unpreview these. And then from here we're going to connect S into C from the endpoints, and then S into the value of lengths. And then I'm going to add in the intersection points. So now you can see that it created two jigsaw joints. So if I go over here and I make this to 3 or 4, that it changes. I'm also going to unpreview the divisions, and I'm also going to unpreview the VB script. So what if we flip it to false now? It flips it the other way. So we need to make sure that it works for everything. So I'm going to unpreview the inside, and I'm going to preview the extrusion curve. It was originally named the jigsaw joint. So if I zoom in here, everything looks fine. So now what if I bake it to multiple curves? What if I want this plank to have many joints? So I'm gonna set multiple curves to 3 curves, and then I come in and this happens. It doesn't give me the joints. So to fix this, I'm gonna go all the way across to where the arcs are, and I'm gonna pick the shortest list. And this gives me the joints so it works. And then I'm going to zoom in and make sure it works. And if I hover over C on the join here, that sometimes on my master definition of this tutorial, before I gave you guys the tutorial, the one that I originally created, I actually had to flatten C in join, so I suggest you guys do the same so everything works. And from here we're good to go. We can add in more joints if we want, control the radius of the joint, control the distance of the joint, and the offset curves. If we want a smaller offset, we can switch it out. And from here we can also extrude these curves so we can boolean out the plank so we can fabricate them easier. And that's how we create the jigsaw joint in Grasshopper. And thanks for watching. If you guys have any questions, feel free to comment us on our website or email one of us on the comment box or comment us on YouTube. Thanks.